All right, hello virtual students. We're going to be taking a look at, let's see, where we left off with question 9 yesterday. Um, let's look here at technology. So we were ending with what we were talking about with scientific inquiry, how we use observations. We ask questions. After we make those observations, we form an inference. And remember, an inference is like an explanation to what we observe. Then we formulate a hypothesis. What we think will happen next is a prediction. We will then go back and test our hypothesis. We will test our hypothesis multiple times. I gave the example in class of if we had four tomato plants and 2 tomato plants had fertilizer and the other 2 didn't. We would be testing to see if fertilizer makes plants grow better. So my hypothesis would be if I add fertilizer to my tomato plants, then they will grow larger tomatoes. Okay, we are going to test that. We would test our hypothesis. If that is true, we would start analyzing our results. We would graph them, we would diagram them, and we would repeat that hypothesis several times in order to see if it is true or not. If we conclude that our fertilizer was correct, it grew our tomatoes larger, taller plants after multiple experiments of doing that, we would draw a conclusion and say that is true. Next, we would want to communicate our results. As scientists a lot of times want to communicate their results through writing an article or a journal that proves what they did that supports their hypothesis. They may speak to the media, and they may speak at conferences in order to get their results out. COVID-19 is a really good example of scientists getting their information out. A lot of times we see doctors on TV speaking about certain medicines that they use to help treat COVID-19. They support whatever that they are saying that has worked for them. Some doctors may think that that's not a good type of drug to use to treat COVID-19. So that's just them communicating what they find and what they've investigated. All right, so results of scientific inquiry can lead to new technology. And such as in the picture in our book, it gave an example of like a prosthetic leg that has like nerve impulses, and it's really just a very high-tech leg that can help do a lot for people who may need a prosthetic leg. So that's been developed. The iPhone has not always been around. That's new technology that's came about. So we hear a lot right now about drones and drones delivering packages, in the near future. That may be something that we see more often than we do right now. New material also comes about because of scientific inquiry, such as in the picture, it's in your textbook on page NOS 8, it's a picture of a bioceramic bone. So it's actually a lab-made bone that can be put into your body, and it can act as if it were a real bone. So that's new material that has been made. Possible explanations and things that we haven't already discovered in our world. The book gives an example of a type of monkey that was discovered in a particular rainforest that was discovered in 2008 and never before been discovered. So possible explanations would be questions such as who, what, when, where, and how would be applied to those. All right, so question number 9, define what are the results of scientific investigations. So new technology, new material, or possible answers to questions had been the answer. Let's look now at the scientific theory versus the scientific law. And it says here that a theory is an explanation or an observation or an event based on knowledge gained from many observations and investigations. An example would be like the cell theory. Until the cell theory is disproven, we will continue to support the cell theory. A law, however, doesn't change. It describes the pattern or event in nature that is always true. Okay, so like the law of conservation of mass, Newton's laws of motion, the law of gravity. These things will happen. If you hold a pencil out in front of you and drop it, it will fall to the ground. Scientific theory, like we said, the cell theory, it will stay the cell theory until it's proven otherwise. It explains that all living things are made of cells. If we ever find something that's alive that doesn't have cells, then it will be disproven. But until then, we will support the cell theory. The Big Bang Theory is another example on how the world was formed. That's debatable. Some scientists support the Big Bang Theory, that this is how the world was formed. All right. Question number 10, what can change a theory? So it says if it is disproved by a new scientific investigation. So until it is disproven, then it won't change. All right. So the way that the scientific laws and theories are similar is that both, it says, they will be rejected if new information does not support them. Okay, and they are both based on repeated observations. Okay, and so here's a chart showing the differences or explaining the theory versus the law. Question number 11. Get to the right one. How do scientific theories and laws compare? So I just, basically went over that. It says a theory explains how and why a particular event occurs, and a law simply states that it will occur. Okay? Question number 12. Summarize why it is important to question information in the media. So let's look at skepticism in the media before we answer that. It's important to be skeptical. Skeptical means like you're questioning, okay? Hang on one second. It says, when you see scientific issues in the media, such as newspapers, radio, television, and magazines, it's important to be skeptical. When you are skeptical, you question the information that you have obtained. Is it accurate? Is it truthful? Where did the information come from? People have a lot of opinions on wearing a mask. Okay? I don't recommend, if you hear someone on the, that is saying that it's okay to not wear a mask and to, you could go to concerts and you should not social distance, I would be very skeptical about their information because they're not paying attention on what's going on around them. So be skeptical. Use skepticism. So why is it important to question information in the media? People who communicate through mass media often do so for their own purpose. They're wanting to support themselves. So that's why it's important to be skeptical. Okay, evaluating scientific information or evidence, So critical thinking is an important scientific inquiry. Critical thinking is comparing what you already know to information that you've been given, or you decide whether you agree with it or not. Identifying and preventing bias also is important when conducting scientific inquiry. To prevent bias in an investigation, sampling, repetition, and blind studies can be helpful to as shown in the figure on the next page. So I really wanted you to read through this. Let's look at this together. Sampling. It says a method of data collected that involves studying small amounts of something in order to learn about the larger whole is sampling. So getting bits and pieces of information from a lot of different places. A sample should be a random representation of the whole. So if I wanted to sample social media platforms for middle schoolers, I would want to, I wouldn't want to do just get 20 middle schoolers who maybe are not allowed to have cell phones and then to tell me what the best social media platform is. No, I would want to get a variety of perspectives of social media and what they think the best social media platform is. So I would definitely want to consider where I'm getting my information from and have a large pool to sample from. That is sampling. Bias it says it is important to remain unbiased during scientific investigations. Bias is intentional or unintentional prejudice toward a specific outcome. Source of bias is an investigation that include equipment, choices, hypothesis formation, and prior knowledge. Suppose you were part of a test for a new cereal. If you knew the price of each cereal, you might think that the most expensive one would taste the best. this is having a biased opinion. So you wouldn't want to know, if you were going to test the cereals out, you wouldn't want to know any information about them prior. You would just strictly, if you were wanting to know which cereal tastes best, go into it with a biased opinion. You wouldn't want to know anything about it and taste test each one. That way you wouldn't think the more expensive one tastes better versus the cheaper one, okay, or the most popular one. A blind study, it says this is a procedure that can reduce bias, is a blind study. The investigator, subject, or both do not know which item they are testing. So you have no prior knowledge of what you were actually looking at, okay? Personal bias cannot affect an investigation if personal bias cannot affect an investigation if participants do not know what they are testing. So that prevents you from being biased if you don't know anything and you're going into it in a blind study, okay? You know, no prior knowledge. Repetition, it says if you get different results when you repeat an investigation, then the original investigation probably was flawed. Repetition of an experiment helps reduce bias, okay, to keep you from having a biased opinion about something, about what you're investigating. If you've worked really hard on it and you want it to have this particular outcome, it's really important that you keep repeating the investigation to make sure that your opinion the first time isn't flawed. You want to repeat that experiment to make sure it's accurate. That's why it's really important when you test your hypothesis, test it over and over and over to make sure you get the correct answer. All right, so question number 13. How can scientists prevent bias in a scientific investigation? Well, by taking it into account when forming a hypothesis and setting up and conducting scientific investigations. That would be the right answer. All right, question number 14. What are some sources of bias? The funding of a source. So if you had a group of people that wanted to fund your particular investigation and they really wanted a certain outcome, that would be a source of bias because they are wanting a particular outcome in your investigation. The equipment that you use in your investigation can also be a source of bias. They may think that the equipment you're using isn't up to date. Okay, they might be biased to you using something else versus what you used. Hypothesis formation, prior knowledge about something. You may be biased about it. Making an inference about data, poor sampling methods. Those are all sources of bias. Not repeating your experiment multiple times, okay, because you like the first answer you got. Those are sources of bias. All right, so that's questions 1 through 14. That was all of lesson 1. It was a very long lesson, and we're still working on it. So here are your vocabulary words. It's a mini glossary. You do need to know these for the test. And you will have a quiz over lesson 1, I believe, in Google Classroom. If not, I will go back and change that, and you will see what you're supposed to do. So thank you for listening, and you'll be ready for lesson 2 in the next lesson. Thank you.